Hey guys, Joker here with the Unknown Adventure, and I wanted to go over my solar setup today, just to kind of give you a little bit of look at how I'm doing things and give you some idea of how they work. Apologize for the wind, it's just a windy day, but I'm wearing these, so hopefully you'll be able to hear me over the Bluetooth. So first let's go up top and see what I installed so you can see my solar panels. Alright, here you go. I've got my solar panels installed. I did these in series, which means that the negative is connected to the positive, so right here's the negative feed, and that comes out to the positive into the negative of the next one, to the positive, negative to the next one, positive, negative, all the way down the chain. So I've got 7 of these. They're rated at 8.8 amps each, and each one is rated at 160 watts, which is 20 volts. So by doing them in series like this, meaning positive to negative, I up the voltage, but I don't up the amperage any. So I'm still running about 8 amps across the way, which means I don't need to go to a thicker cable other than the 10 gauge. That'll be enough. And this keeps my voltage up to about 140 volts. Maximum voltage on my PV system, on my MPPT charger, is 150 volts. So this maxes me out pretty well. The reason to do it like this is if one of these is in partial shade or on a cloudy day like today, you still get enough voltage to push on the batteries. Now you can run them in parallel as well, but usually for RV like this, you run series. So let's go down and take a look at where it goes into the bus. Okay, in here, the solar cables come in here, right in through here, through the cover that I put up there, and you have the positive, negative. They come down in here. I have it going into a switch, which I've currently got off. I'm draining the batteries a bit so I can test my inverter, and they go into the charge controller here. And you can see right now it thinks it's in night mode because I've got the switch off and I'm draining the batteries. From here, and I'll turn it on to show you what it does here. So with that switch off, it thinks it's at night and it's running the battery. From there, I come down into a 100 amp fuse or a 100 amp breaker. I'm going to be switching this over to the fuse because even though this breaker says 100 amps, it kicks off lower than that, and I don't want it to do that. From there, we have it coming down here into the batteries. Now the batteries are in parallel, meaning all the positives are together and all the negatives are together. So with the solar panels in series, that ups the voltage but keeps the amperage the same. Here, by running them in parallel, I want to keep this as a 12-volt system, so I don't want to up the voltage. So by putting all the positive and the negative together, I'm upping my amperage, but not my voltage. Each battery here has a maximum of 700 amps it can put out at once, and so as such, I can put out 210 amps times 12 volts, which will be pretty close to 2,400 watts, pretty close to there. So that's going to be more than anything I need. I ran smaller cables between the batteries, but I doubled them up. And then to go to the inverter, I have a positive and negative going up. Again, now that's a 250 amp breaker, but it blows at about, and it pops off at about 87. So that's not going to work either. So I have a fuse on the way to replace that. I have a 250 amp slow burn fuse to replace that. I originally wanted to do breakers so that if I wanted to kill the system, I could just push a button and it'd kill it. Unfortunately, they're just not strong enough to take the amperage that goes into this. I tried running an air conditioner off this at about 1,000 watts, and it popped, and that shouldn't have been but 80 amps. So I'm just going to go with the fuse block there. So this comes into the system here, and this is a 3,000 watt pure wave or a pure sine wave inverter. This is important because you need the pure sine wave, not a modified wave, to run things like refrigerator motors, fan motors, computers, TVs. The modified wave is good for like power equipment. These are going to be much more expensive though. A 3,000 watt unit like this cost me about $700. But the nice thing is that even with the fuse protecting the line here, and the fuse protecting the line here, and the power switch here, I can turn off the solar panels and the charger. This doesn't get any more solar power. Once the fuse is in here, if too much amperage comes out of that, you want to match the amperage of the fuse to the amperage of the charge controller. That'll protect that line in here, and then from there, obviously, I'll have my fuse to protect my inverter. 250 amps at 12 volts is going to be 3,000 watts exactly, which is what the inverter is. From there, it gives you a couple of plugs. These are both 20 amp plugs, but that's 20 amp at 120 volt. So that's going to be 2400 watts here as well. And then this one, you can connect the raw lines of an electrical cable in here if you want all 3000 watts available. I don't. I wanted to use the GFCI ground protection that this has in here. Now, it has one in here as well, but I wanted it to be able to trip this should there be a ground fault. And then from there, since there's only 2 plugs here, I have a lot more things to plug in than that. So I just put in a 20 amp extension, which has 4 plugs in it. And now I could have put this into a normal fuse box on the wall, like you see in a house. But instead of that, this is a much cheaper option, and it's much simpler. If anything gets drawn over here, over 20 amps, I have this safety breaker that'll blow. I have the GFCI that'll blow. I have an internal fuses inside of here that'll blow. I have that'll blow at 250 amps. So again, everything has redundant safety, and this was a cheap option. This is just a 120 volt cable that you can run through the house here. And what I did is I have like kitchen sink equipment, and then here I have the kitchen refrigerator, and then here I have my desk. And all I did is I made these plugs. They're about $6 each. You can just order them online. I made those plugs right there, and they just plug into a normal socket, but they'll change your household 110 or 120 into a household plug. And it just runs down the wall there and scoots out behind my bathroom. And then over here you see the other one, the plug right there. I haven't fixed the wiring yet, but that's all going to be hidden up in the ceiling. That goes up there and down the right-hand side. Then the only other thing I have is negative and a positive here coming up to my fuses, and that's for my lights for right now. I may hook up a couple of fans here, but I really don't have too much I need to run off of the 12 volt. Although you could hook a refrigerator up to 12 volt, mine is a 120 volt. So all my cables go behind the bathroom here, and I have my water and my cables and everything back down in there. Kind of hard to see, but I've got my electrical cable and my water coming through here. This is my fill for my tank, and you'll see the cable there that I ran down from the ceiling down through this PVC and into the wall. I haven't finished my wall yet. And then I just terminated the household cabling with another female plug in which I can plug in my receptacle. So over here for the desk, I just went to a surge protector. And that gives me, let's see, 2, 4, 6, 8 outlets here plus a USB charger. And as you can see the little light there, that's charging and it's working fine. One of the other ones I have coming over here to a normal receptacle. I wanted that to look nice. Underneath the desk here where I have my other cabling, you won't see all that. That'll be shoved underneath the bed. And this is where the bed goes, and I'll have a bed skirt coming down here. So all that'll be hidden underneath there. Here I have a regular GFCI connector. So as you can see, I'm double protecting just about everything. And my fridge, which I have running into this cabinet. This cabinet's not in place yet. I'm running cedar down the inside of it, but they're out of lumber right now at the Home Depot, and I can't go out anyway. So I'm going to side this with cedar and slide it up there. And then underneath the sink here, I have the one connection going up to that GFCI connector, and the other one just going down there for the refrigerator. So I have the refrigerator running separately. And then the other one I have coming all the way down that wall, like I showed down there, I have that coming underneath the desk here. And I have that just terminated at a plug there. And I will put this into another 20 amp 4-plug office protector, and then all my electronics, like my microwave and things like that, that are going to be on top of the cabinet, I'm just going to run that probably behind the lip here, and then through a hole down in there. And that way I can have my microwave, my coffee maker, maybe a toaster oven, a hot plate, or whatever I'm going to have in here, all lined up and plugged into that. And that's the solar. So on the 12-volt system, the only thing I'm running is 2 wires that come up here into the lights. And you can see, so I've got all my 12 volt coming across there. And that's not in yet, obviously, completed, because I've still got boards to put in here, the cedar boards to put in there, and to finish off my wooden trim. But the rest of it's in, and it's looking good. So that's pretty much all the electronics. The one thing that gave me a lot of trouble is whenever you read manuals that say how to install a system, they always talk about grounding everything, and they say, oh, you want to make sure to ground this to the chassis. Well, the thing is, this is an entire floating system. So the reason why normally you use a chassis ground and connect it to the chassis is so you don't have to run so many negative cables. So for example, if I was going to run a positive up, say for example, to run my refrigerator with a battery ground system, you have to run a negative all the way back to the batteries. Well, if you ground the batteries to the frame of the vehicle, you can then ground your positive, or put your positive to your device up there, and then as you come back, your negative only has to ground right there to the frame. I didn't want to do that because the battery system for the bus that runs the bus and the engine it's two different batteries. Those are engine batteries, and I didn't want to get a ground loop. So this is totally enclosed. So the only thing that this system grounds to is those negative terminals. It is not a chassis ground. So here we'll see, if I throw on my solar panels, you'll see that this will start reading that it's daytime. And you can see it's bringing in 142 volts. The maximum this will bring in is 150 volts. So even on a cloudy day, you'll see it spike up to 140 volts. Now, if you're asking yourself why it's only showing the voltage here at 3733 and it's dropping off, is because my batteries are full. And as such, it's really not drawing in the power because my batteries are full. And when the batteries are full, the charge controller will regulate how much these are bringing in. And that's all there is to it. So there's the entire system from top to bottom. And then, yeah, so that's pretty much it. It's pretty easily done, pretty easily run, and that's it. So I have a few more things to put in as far as fans on 12 volt. But other than that, my system, my electricity is done. I've got 3 kilowatt hours of battery, which is enough to run my fridge all night, enough to make coffee in the morning, enough to cook something at night, enough to run my computer for 4 to 6 hours. So that should be more enough to do everything that I need. Guys, this is The Unknown Adventure. This is my electric install, and this is Joker. We'll talk to you again soon.